In an era where our lives are conducted more and more online, the topic of data security becomes a big issue for both the user and the web service. Even large companies with enormous resources fall prey to data breaches. Target became the target of a mass data breach in 2013 where sensitive information was stolen from millions of customers. And in 2014, roughly a billion Yahoo user accounts were compromised. Data breaches are unfortunately inevitable, but there are strategies web services can use to prevent hackers from gaining access to user accounts. I'll be describing one such strategy, evolving from a naive approach to one that mitigates the effects of a breach as much as possible, based on the experience I've gained as a web programming major at Purdue. So first we'll start with the naive approach. Here's an example of a user database. When you create a new account, your username and password is inserted into that database. When you try to log in, the web service simply checks to make sure that the username and password that you provide are the same as the ones that are found in the database. Now there's a big problem with this approach, and that's the fact that all the passwords are stored as plain text. That means that if a hacker gets access to this database, he or she can compromise every single account in the database. So how do we combat this? I mean, surely we need to know everybody's password in order to make sure that when they log in, they type in the correct one. This is where a hashing algorithm comes into play. A hashing algorithm is an algorithm that takes an arbitrary text input and produces a random fixed-length string of characters as output. There are three important properties of a hashing algorithm. The first is that the hashing algorithm is deterministic. That means that if we provide the same input to the hashing algorithm, we should expect the exact same output every time. Another important property of a hashing algorithm is that it be chaotic. That means that even a minor change to the input, such as an uppercase R instead of a lowercase r, should produce a wildly different result. And the last and most important feature of a hashing algorithm is that it be a one-way or a trapdoor function. That means that it's very easy to generate the hash from the input, but it's almost impossible to get the input back from the output. This is similar to how it's very easy to put a coin into a piggy bank, but it's very difficult to get it out. So how can we use hashing in order to improve password security? Well, we can simply hash all of the passwords that are in the database and store that instead of the plain password. So when a user creates a new account, we store their hashed password, not their actual password. Then, when the user attempts to log in, we hash the password that they provide at login and make sure that the hash result is the same as the hash that's stored in the database. And if it is, it's a successful login. There's still an issue with this though, and that's the fact that a hacker can use what's known as a rainbow table in order to extract passwords. A rainbow table is a table that contains millions and millions of common passwords as well as the hash values that they evaluate to. So in order for a hacker to get your password, all they have to do is look at the hash that's in the user database, see if it's in their rainbow table, and if it is, they can deduce your password. So how do we prevent a hacker from using a rainbow table? We can do this by using what's known as password salting. When you salt a password, you add a random string of characters to the end of each password, and then you hash that instead of the plain password. So if you look at our table now, every user has a password salt and a password hash. So when a user account is created, we generate a random string of characters as the salt, and then we append that to the end of their password and then hash that and store it in the database. Then, when the user logs in, we look up their username in the user table, and we see the salt that's associated with that user. Then, we append that salt to the password that they provided and hash that. Now, if this hash result is the same as the hash result that's in the user table, we know that they've logged in successfully. So, this prevents a hacker from using a rainbow table because now every password has a random string of characters at the end of it, meaning that it's very unlikely that this password with the salt attached to it is going to show up in the rainbow table. What's more is that if two users have the same password, even if the hacker can deduce what one of the passwords was, because the salts are different on the same passwords, the hash is going to be different on each password too. So if he can crack one, he won't be able to crack any others. So using salting and hashing means that the hacker is left with guessing each individual user's password one at a time. This is still possible, though, to guess your password if you have a weak password. If your password is password, or if your password is name or your birthday, a hacker doesn't need to have access to a database in order to guess your password. So remember that a good password is long and strong. Every additional character that you include in your password makes it roughly 70 times harder for a hacker to guess. Secondly, your password should be unique. That way, if one web service is compromised and your password is discovered, the hacker can't use that password on your other accounts, such as your Gmail or your Facebook or whatever. And lastly, your password should be impossible to guess. A challenge I like to keep in the back of my mind when I'm choosing a new password is, can I choose a password that has never been used in the history of passwords by anybody? It's a lot easier to do than it sounds, and if you can ensure that, you can also ensure that your password is not going to show up in a hacker's rainbow table. So always remember that your first and last line of defense against a data breach is a strong password.